Hello, everyone. I'm Dr. Donyall Dickey, founder and CEO of Educational Epiphany, one of America's fastest growing publishing and professional development companies. And I could not be more excited than I am in this moment to introduce my co-hosts, Richard Bork.
Hello, everybody.
And Jerry Richardson.
Hey, hello, everyone.
Thanks, everyone, for tuning in to this episode of the Epiphany Exchange. Richard, what are we talking about today?
Ooh. Well, the title of the episode is called Simplifying America's Math Problem. And I mean, personally, that's like super enticing to me because I remember getting in my freshman year of high school and being like, what? I don't know anything about math. I thought I did. I got into my Algebra 1 class and I literally think within the first 3 weeks of the semester, I mean, I was cooked. I didn't have a way out. Like I was so far, the pace moves so fast.
Yeah.
There's way more pressure. I felt like there was a little bit less support and that I was just supposed to know the concepts to help me get through this next level of math.
Wow.
And I just didn't.
Yeah.
Like I just hit this brick wall.
And did it create a fear of math class?
100%. I ended up actually, America, I'm exposing my academic challenges. I actually ended up moving into Algebra A my freshman year.
Which is a class designed to help you clear up misconceptions so that you can get back on track.
Right.
Fantastic.
So I did Algebra A. I got a tutor. I did all the things. And then like I got my footing again.
Yeah.
But I'll tell you what, that was stressful. Yeah. I actually felt like no one was teaching me how to actually accomplish what the problems were asking me to solve. Like, what are the steps that I need to take?
Yeah, and far too many children in our nation feel the same way when they contemplate even entering a math classroom. And so this podcast is timely, and I think we will help a whole lot of people with it. Jerry, aren't you a former math teacher?
Yes, absolutely. And I think one of the biggest things that I've had to deal with is that math is a puzzle. And so looking at it with students and thinking, what tools do you need in order to solve that puzzle?
Yeah. Yeah. And I think as a former third grade teacher, as a former high school teacher, former assistant principal secondary, former principal secondary, and on up the line, I got better at teaching and supporting mathematics as my career progressed.
Yes.
And so I remember being a third grade teacher of all subjects. And God, I'd love to apologize to the children that I taught in 1996 mathematics. Honestly.
I was 5.
Excuse me?
I was 5.
You were 5?
Yeah.
Okay, well, twist the rusty nail.
I don't know, Doc. Don't beat yourself up, Doc. I'm sure they're all like accountants and like.
I'm sure.
Finance.
I'm sure.
I certainly hope so. Yeah. But because I wish I knew then what I know now about math. And as an elementary teacher, I wasn't trained in math and social studies and English and science.
Right.
I was trained as a generalist, but I was responsible for teaching math during a critical period.
Yeah, absolutely.
Right.
Yeah. I was an elementary school teacher too. And so stepping into that role, I had to understand like students must know that math is a creative space. And no one ever taught me that. How can math become a creative space? How there's multiple strategies, how kids can come up with the same answer, but use different things to solve it. You can create your own strategies.
Yeah.
It really can make
that feels like freedom, but most math classes in this country don't feel like that. So Jerry, that feels nice and marshmallowy, sort of like that school district you used to teach in Virginia.
Yeah, I'm sure.
Shall I name it?
Please, no. I have them comment on it.
But the point I'm trying to make, and I'm not making fun of the school district that I will not name, where you were a teacher. A lot of kids feel like Richard described.
Yeah, lost.
Right? Yeah. And that
scared,
sometimes that exploration creates even more anxiety. So then how can we balance explicit instruction with exploration of mathematical concepts.
That's correct. I feel like it has to be a balance.
A nice balance. Yes. So that's what we're going to talk about today.
Yeah, that's a really good point, Doc. And I wonder, one of the things Jerry and I wanted to ask you is about like how you would describe some of the like traditional or even possibly harmful ways that folks conceptualize teaching math.
Yeah. I don't know if I said this before, so if I did, I apologize to those who are watching and listening. But as much as we talk about ELA and talk about the gaps that kids have similar gaps in math.
Oh, for sure.
Both in knowledge and ability.
Absolutely.
Right. And so if we're going to be a competitive nation as it comes to math and science, we've got to move away from this traditional approach to conceptualizing, teaching, and planning and assessing math instruction. So that's a good question. So here's my short answer to that question. There are 4 harmful and traditional ways that mathematics instruction has been approached. Number 1, algorithm driven. So even in your description, Richard, of how you hit that brick wall in algebra, you were describing the steps that one must take in order to solve a problem. And if I remember my early grade mathematics experience, I remember the same, being told, here's step 1, here's step 2, here's step 3, here's step 4. When you finish step 4, circle your answer. That's doing math, but it's not necessarily understanding math.
Absolutely. Right. Yeah. And it's missing. And so now that's why students have to go through that now, the process of saying, hey, what's the concrete version of this? What's the representational version of this? And now what's the abstract? And which is what you were taught.
Yeah.
You were only taught the abstract way.
Well, I never said that, Jerry.
Okay. The way, Richard, you are describing.
Well, I also want to hit on something you said, Doc, which is like the steps that we were taught.
Yeah.
I would forget the steps too.
Absolutely.
Of course you would.
I'd be like, wait, what's step 3 again?
Particularly if you weren't required to at some point take notes on the steps. So at least you could do the work, even if you didn't understand the work.
Right.
But back to what Jerry said, though, about concrete, representational, and abstract. So I hate to get ahead of myself. So I'd like to give some insight to the harmful ways that math can look before we solve it. So, but you're right, Jerry. Algorithm driven is just one way to solve a problem.
Abstract.
Yeah, that is to follow the steps, and it is not necessarily going to help kids to understand what they've done. So you're right to call up and to our attention CRA, concrete, representational, abstract, so that when kids are trying to get to abstract understanding, which is like to do it in their head, concrete and representational will stand in that way, but I'm going to come back to that. Okay. All right. Yeah. So algorithm driven. So if math instruction is only about performing the steps and circling the answer, you've done math. You have not necessarily understood it.
Right. You're not going to break the algo doing it that
way.
Well,
you're not going to build a rocket to the moon if all you know is the algo or the algorithm.
Right.
Yeah.
Okay.
All right. Then secondly, math instruction in this country that is harmful to kids, it's spiraled. And that's going to sound bad to some people.
Spiraled.
Yeah.
I mean, that's what I was, when I joined the teaching profession, I was told, it's okay. It's okay they don't get it. It's going to come back again. Yeah,
but there's nothing wrong with a spiral curriculum, because you know what it means. What it's supposed to mean is this. Well, when kids master it the first time, they need another opportunity to practice it later. But notice what I said. When kids master it the first time, they need another opportunity to practice it, which means the first time when they were taught it, the assumption is that they mastered it.
Yes.
Right. In Aiden's Algebra 1 class right now, they're doing like the New York State is saying like you have to take this one chance to master this concept. Then you have another two chances to like do it again. And then there's like a final conglomerate, like the way that they're scoring the test is like, it's so intense.
Yeah.
And it stresses the kids out.
Yeah, I'm sure it does. But let me take a step back to the curriculum, because the curriculum is supposed to either mitigate or never allow these stressors to form in the kids' like psyche about math. Because a spiral curriculum that is taught in a way that has a hyper focus on the spiral nature of the curriculum, it sort of like promotes teachers to rush through it. To your point about don't worry about mastery, we're going to come back to it anyway.
Correct.
But it's spiraled so that the second time they see it, they stand up inside of the mastery they got the first time they saw it.
Right.
But folks are moving so fast to get to the end of the curriculum that the spiral curriculum is not living up to its structure.
Right. It's fast paced. It feels like it's rushed.
Right. Because look, if let's go to elementary. If adding fractions is in the curriculum 4 times, quarter 1, 2, 3, and 4, why not teach it really well in quarters 1, 2, and 3? And if I don't get to it in quarter 4, that's okay.
Right. I see what you're saying.
Yeah. So, but if I rush through it in 1, 2, and 3, I'm going to need to teach it again in 4 because I never mastered the first time.
Right. That's crazy. My head is jumbled just thinking about like having to keep track of all that as a teacher. Yeah,
which is why I try to say to folks who allow us to come into their schools and districts, I'm going to say some things that are contrary to the ways that we have like imagined instruction. Is that okay? You really want me to come? And so I help folks to not speed up to a red light, which we've talked about in the previous podcast.
Right.
Okay. Now, number 3, the third way that instruction math instruction has looked in America, and it has been harmful to kids, is a mile wide and inch deep approach.
Mile wide and inch deep.
Mile wide, inch deep.
Okay.
Right.
Which means I'm going to cover, but I'm only going to cover these things superficially.
Yes.
So superficially that when they get to a complex mathematical problem-solving situation, students, that is, they grapple because they have limited or finite knowledge of discrete math concepts.
Yeah. I know, but I hear from teachers all the time who say, I want to make sure by the time the kids have left my classroom to go to the next year, they've been exposed to the curriculum that they're supposed to know from that current grade.
Yeah. Okay. You say they want to be expose children to the curriculum. Step back from the curriculum. You want kids to be exposed to a given number of concepts.
Okay. Yeah.
That are in the curriculum. Right. So it's the concept. So what are some of the concepts that kids will see? I'm getting ahead of myself, but you're pushing me there. What are some of the concepts that kids will see? They'll see operations. They'll see, I'm talking about elementary. They'll see algebraic thinking. They'll see measurement and data. So there's a finite number of concepts within those domains. And you can cover the domains in a way that is strategic. And so but one of the ways to be strategic is not to rush.
Right.
Yeah. Because you're still going for mastery. Right.
And transfer.
Right.
Which is greater than mastery. Like transfer says, I mastered it so well that I can transfer to another situation without being prompted.
Right. And if you master it, it's a mile wide and a mile deep. Right?
That's right.
You got that foundation.
But an inch deep, there is no transfer.
Right.
There may not even be mastery.
Still surface.
Yeah. So we have to manage the tension between wanting to finish and wanting kids to understand what we have finished.
I understand.
Yeah.
Darn pacing.
It seems to me like
we're not anti-pacing. I'm sorry, guys. We're not anti-pacing. We're over-reliant upon pacing.
Yes, that's exactly
right.
I'm hoping. Thank you.
Because we have to pay attention to kids.
Yeah.
Individual, like what kids need in that moment in that classroom.
That's right.
And that might not always meet that pace.
Right. And an inch deep does not meet everyone's need. There's some kids who are going to come already ready. And then there are others, which is most kids in America, they don't come ready. So inch deep does not help them to progress in mathematics. So when they get to high school, they won't hit that brick wall.
Love that.
Yeah.
Okay. All right. Now, the fourth way that traditional mathematics instruction has looked at is dangerous for kids is purpose disconnected math work.
Purpose disconnected math work. What does that mean?
What does that mean?
It means that kids are doing math without the math connected to a real world purpose.
Yes.
Like here's a page full of math problems. Add these 2-digit numbers to these 2-digit numbers. Go.
Yes.
Are you saying like make it tangible?
Make it conceptual.
Yeah.
Conceptual.
Right.
Okay.
So when you're teaching area, connect the teaching of area to tiling a floor.
Right. I mean, you see that often. I mean, I call it like naked numbers. You know, so typically I do give, you know, I would give a student naked numbers, but only after I've already exposed them to a real world situation so that they can conceptualize the math.
Yeah. Thanks for this new phrase, and it's now stuck in my head.
What is that?
Naked numbers. So naked numbers. And you tell kids naked numbers? Or is that in your perverted head?
Perverted. I think I've said it like in the POC.
Oh, okay.
Like
Got it.
around adults.
Got it. Okay. Yeah. So, you're right though, Jerry, that naked numbers, I can't believe I'm saying this out loud. They have a place in math instruction. Mm-hmm. They do, because discrete mathematics roll up into multi-step, complicated, worthwhile mathematical tasks.
That's correct.
So it's important for kids to be able to subtract with automaticity or add or multiply with automaticity. That's a naked number experience. Mm-hmm. But you don't want to leave it there. You want to put it in a situation so they can grapple and problem solve and think critically.
It's like you were telling me, it's funny, I didn't even think of this for this episode, but what you just said sparked this in my head. You were talking about a kid that you ran into recently with a multiplication chart.
That's right. Kareem, North Carolina.
Yeah. Fayetteville
area. Durham area.
And what you did with him was awesome.
Yeah. So we were doing, I was teaching a math lesson to fifth graders. Mm-hmm. Kareem and his team of a group of like 15 or so kids, small charter school in North Carolina. And I was doing a demonstration lesson with maybe 15 or so teachers watching. And we were multiplying 4-digit numbers by a 1-digit number. And so I was showing them like an expanded form approach, which is not a standard algorithm. Right, it is another way to solve that problem, to Jerry's point earlier. And I realized that after I modeled a problem, so we were multiplying like 2,550 times 5. So I did 2,000 times 5, 500 times 5, 50 times 5, 0 times 5. Mm-hmm. So that he could, and then do the math, add those up.
Right.
Because when children try to multiply using the standard algorithm, carry this, carry that, regroup that, right? Mm-hmm. They fall apart. So I was showing them there's an easier way to do it conceptually. So if your brain works this way, you might want to use it in the future.
Right.
And what I discovered rather quickly is that he had two issues. Right. Other kids were able to see the model from me and do the work expeditiously. Right. But Kareem had a problem because I was looking over his shoulder and I realized, he has a problem with quick multiplication, like math facts, right? But he was he was resilient. He did not give up. Yeah. And he did not want to fail me. He did not want to fail himself. He wanted it badly. Yeah. And so here's what I had ready for him, because I understand kids. I gave him a multiplication table. I had it already copied, because I could anticipate I would meet some kids who were not as quick as I wanted them to be with multiplication facts. And so I showed them how to use it. 8 times 3, 24. 5 times 5, 25. So then I said, but when you see 2 zeros on one of the numbers, you got to add 2 zeros on the end. Boom, he got it. Right. That wasn't his problem anymore. Then I realized place value was his issue. So once he had the expanded form numbers all lined up, he might have had 25,000 plus 1,600, but he didn't align the one in the 1,600 to the thousands place and the number above it. He was shifting them over. Right. Which was screwing up his ability to get the final answer.
Yeah. One wrong move in math and
it falls apart.
Right. Yeah, it's a house of cards.
You're getting an F on
it's
that
house of cards. That's the problem with algorithm-driven instruction, spiraled instruction, mile wide and inch deep, and purpose disconnected math.
Speak it. It's so true.
Because kids, gaps form.
Yeah.
Because we're trying to cover without looking over their shoulder to see, there's a tiny issue this kid is having. If I can solve that issue, he can be successful. And boy, was his chest sticking out when he figured it out.
Right, because when gaps form, right, confidence decreases.
Correct.
Absolutely. All right, so now we talked about the dangers. Yeah. What should we be teaching? How should we be teaching math in a conceptual way?
Yeah. So I think not only am I going to lay out for you how we should teach math, I think really it's more about how we might conceptualize math. Okay. And therefore, what we do will be a byproduct of this understanding.
Okay.
Right?
Yeah, that adds up. Sorry.
I love that.
Sorry.
But great. Your timing is impeccable.
Gotta find one.
All right.
I want to say one now.
Please, no. All right. So
track that.
So if these 4 ways are not helpful to kids, then what ways are helpful to kids for us to conceptualize math instruction? So here it is. Number 1, and please stop me for clarity. Number 1, focus.
Focus.
Math instruction should be conceptualized in a way that is focused, which means I'm going to teach a few things well.
Really?
Okay. Why? Because people before Richard failed to teach a few things well before his Algebra 1 class. I'm not indicting your teachers, Rich.
No. I love my St. Joseph's teachers.
Yes, sir.
Yeah.
Yes, sir. But it's very possible. Now, I'm not saying Richard was paying attention. He was a perfect student every time.
No, definitely not.
Right?
Let's not put that out there.
I'm not saying that Richard's behavior was perfect.
No.
I'm not saying that Richard's attendance was perfect.
Math. When it came to math, I was disengaged because I felt completely lost. My attendance wasn't perfect.
Okay. All right.
A myriad of concerns.
Okay, gotcha. Right. So there are factors that are related to the student, the learner.
Yes. Right.
But then there are factors related to how the adults might be conceptualizing and supporting math instruction, and focus is one of them. So let me delve into that one just a little bit more. It's about how teachers decide to narrow and deepen the scope of how time is spent in the math classroom.
Who determines that?
I think I know the curriculum plays a part, but the curriculum is not standing in front of kids.
Right.
So the teacher makes that decision in collaboration with peers, in collaboration with leaders.
Okay.
And so this just means that if I don't finish everything I want to finish, what I did finish, did they deeply understand it? That's focus.
I understand. And I'm looking at I can be looking at previous year data to inform my focus for the current school year.
Absolutely. Okay. And real-time data, right? Because if I realize that I'm teaching kids how to complete a function table and I realize they get it, I can move on.
Okay.
I don't have to do what the curriculum guide says, which is what? Teach it for 17 days till they're blue in the face. Right. I can move on. Right. And so it's about you're right, to link this to data, it's about using past or recent and real-time data to make a decision about what I do and how long I stay there.
Okay.
Focus.
Yes.
Yeah.
Okay.
Okay. Number 2 is coherence, which is about ensuring that we approach the teaching of mathematics in a way that new concepts don't feel new. They feel like an extension of what has just been covered and mastered.
That's correct. Because a lot of those concepts that students are being exposed to, it's a building block.
Yeah.
And they have to understand, hey, we did this. You guys did this last year. Now we're building on it for this current school year. Yeah.
And not even just the current school year, but unit 1 to unit 2 to unit 3 in the same school year. Yes. So that if I've taught kids to simplify expressions and the next step might be to solve equations, that's coherent.
Yes.
Yeah.
So I'm going to be looking in the same school year to find coherence.
Oh, yeah. Within and across. Yeah. Which is the purpose of vertical articulation, which is the purpose of long-term planning. To say what's in unit 1, how is it naturally connected to what's in unit 2 and so forth? What was in pre-algebra that is naturally connected to algebra? What is in geometry that's naturally connected to algebra 2?
And if there's no connection, there's no connection.
There is one. Don't force it.
Okay.
But coherence says I have a plan to make sure that when I introduce something to kids, I say to kids, hey, guys, remember I just taught you X? Now, let me build a bridge to Y.
Okay.
Yeah. So wherever there is that connection and whenever it happens, you want to focus on it and make sure that it's being...
Acknowledge it and exploit it.
Yeah. There you go. I love that.
All right. Number 3. So in addition to focus and coherence, procedural fluency. And procedural fluency is about kids being able to do with speed and accuracy minute calculations, which is what Kareem was grappling with. Yeah. But if you are struggling with I just remember being a little kid and my math teacher would say, stand up, count by 5. Yeah. Stand up, count by 7. I mean, a little hard beating you through your little shirt, whatever. But she was trying to make sure that when we got to complex multi-step problems that we didn't fall apart because our issue was simple calculations.
Isn't that explored during the number sense routines? So if students are sitting, you can't use any paper, you can't use any pencil. You literally have to just use what's in your head.
Yeah. Procedural fluency, I think it's a part of like number talks. And what is a number talk? Like, hey, class, we're going to be dealing with rounding. Okay. So rounding means, an estimate. Correct. And so we're going to round to the nearest 100. So it's 555 closer? Is it 600 or 500?
Correct.
Yeah. And it's just having a conversation about it and ultimately saying to them, it's all about the midpoint. Stop that 4, stay on the floor, 5, go up high. That doesn't help kids to conceptually understand math.
Okay.
Yeah.
What are you thinking, Jerry, about my knowledge of mathematics? Because people typically try to typecast me as a reading and literacy specialist.
You know everything.
I wasn't
Dr. Dickey. No, but they're like, Dr. Dickey, what did you teach? And you're like, that's the experience that people should have with you.
That's
they
right.
should know what
You're
your
not supposed to
specialty
know.
was in your higher education.
If I say that I'm an instructional leader.
Yes.
Right.
So I'm not a math person.
Yeah. Because Richard, as a former principal, I would never say, or I'm not a science person.
Right.
Because then the people that I'm evaluating would not have confidence in my feedback.
Yeah. You talked about that in one of our, it was the beat on the street when we had folks call in, right?
Mm-hmm.
Yes.
And one of the folks that called in was asking about like different content areas as a leader.
Yeah.
And you said you have to be the master of multiple content areas.
Yeah, I think that was right.
Yes.
Yeah, absolutely. So focus, coherence, procedural fluency are ways that we can increase the quality of the instruction that kids receive. Number 4 is conceptual understanding.
Okay.
And you guys hear me talk about, conceptual understanding all the time. It's the opposite of tricks. It's the opposite of mnemonics. Mm-hmm. It is making sure that children can use the language of mathematics in a situation.
Yes.
Yeah.
Yes. And I found that so important. Like math is its own language. And how do we expose students to that language to make sure that they're calibrated? And so oftentimes I'm interacting with children and they're doing multiplication. They have no idea what multiplication means.
Right.
So it's hard for them to unlock. There's other strategies associated with multiplication, such as repeated addition.
It's a brick wall that Richard described. Because if I've been painted in the corner with the standard algorithm and you ask me to use an alternative strategy to solve a given problem, and I don't even know that there's a universe of other ways to solve it,
Yeah.
it impacts my creativity as a math thinker.
Absolutely.
It's funny because I actually, like, by the time I made it to physics, I think it was my last year of high school, I did so well. And it was because I had like things in front of me and actual like concepts that I could see and creatively think about how to solve.
Yeah. It sounds like you got your hands on some manipulatives, but we'll get to that.
Yeah.
Okay. All right. Number 5 it's about application. So you got focus, coherence, procedural fluency, conceptual understanding, and application. So I hope these things are going to flap on the screen for folks to see.
Absolutely.
All right.
Yeah.
All right. So what's application? I've kind of already alluded to it in our initial discussion, but application is about kids being able to use their procedural fluency and their conceptual understanding to apply it to a situation, which is the opposite of purpose disconnected. Application is the direct opposite of purpose disconnected.
Yeah. So you see a lot of that in like problem-based learning. So give them a problem and students have to be able to then solve it.
Yeah. And, some folks believe there are at least two ways to think about math instruction. One, explicit.
Yes.
2, inquiry-based, or some folks say constructivist.
Yes.
And so some folks say, well, hey, kids, just take, here's a problem. Go ahead and take these pieces of plastic. Go ahead and solve the problem.
Yeah.
That is acceptable. And
that's my way of teaching.
Yeah.
Well, not all the time.
Yeah.
It depends.
Of course.
Yeah.
And there's another way. Hey, kids, here's step 1. Watch me. Here's step 2. Watch me. Here's step 3. Watch me. Now, guys, go ahead and repeat the steps. Let me see where you're falling apart. Both of those are valuable. I don't think one is better than the other.
And now apply it
to a situation. Okay. And then finally, number 6 is dual intensity. And so what's dual intensity? It is a math classroom wherein students time is devoted equally to practicing and understanding, to doing and understanding.
Practice makes perfect.
Practice makes more practice.
Right.
But it seldom makes perfect, honestly, because when how do I say this? When different variables are thrown into a mathematical problem solving situation, a math problem that looked familiar to kids starts to look unfamiliar. And so there's always a way to make the math problem more complicated, to challenge kids who are ready for those additional challenges. And so I would say that certain practice could make perfect. But you want to constantly challenge your highest performing kids in the classroom to make them imperfect again, so you can perfect their thinking again.
Right.
Up the scale.
Right.
I think I'm struggling with dual intensity. What does that look like?
Yeah. It's a math classroom wherein students, let's say they're solving a problem. They know how to perform the steps. They know how to use the formula. They know how to choose the tool strategically, right? That is like doing the work. That is the minute steps or calculations that they have to perform. That's doing it.
Okay.
But a lot of kids in our country, they might do step one, but they don't know why they did step one. So why did I put, okay, let's say I'm going to multiply 5 by 2/3. Why do I put a 1 under the 5 before I multiply 5 by 2 and 1 by 3? Why do I do that? Because 5 wholes is the same thing as saying 5 over 1.
Right. Yeah. That makes sense.
Yeah.
That makes a lot of sense.
Yeah. Okay, let's say I'm going to plot points on a coordinate plane because I completed the missing values in the function table. And every time I determine the value of x and the y domain in the range, or the x and the y domain in the range, I see that there's a proportional amount of space between each x and each y. That I'm going to do the math. I'm going to plot the point. But understanding is when there's proportionality between the x's and the y's, the x's respectively, the y's respectively, what kind of line will end up on the coordinate plane? A straight line.
Right.
Because kids will do the math and not think, wait a minute, as the x's and the y's are proportional, I'm going to constantly have a straight line.
Right.
Linear versus nonlinear.
Right.
What are you thinking?
No, I was just thinking like, this is where the opportunity I see where students have to be able to fully think about their steps and why, and the choices as to why things are working and why, like they're, I don't know. I feel like it's their way of like having their own metacognition of like what's happening and why.
Right. But I think we're so preoccupied with finishing, and teachers have been, whether it's perceived pressure or it is self-imposed pressure, educators feel like they don't have time to get them to think. They have time to get them to solve the problem.
Yes. Dang. That makes sense though. That makes a lot of sense.
And then it ends up with like the tutor or after school or.
Yeah. I felt the same way as a math teacher. Hurry.
Absolutely.
Yeah.
It's like
I feel that as a parent
pace.
with the emails every week from the teacher, like we're covering this today. We're covering this today.
Yeah. Now some people need to. I'm not saying that no two snowflakes are alike. So like some people are slow. They need to speed up.
Right.
Yeah, for sure.
Some people are too fast. They need to slow down. But I don't mean slow down. I mean be intentional.
Two different things.
Yeah. Watch the room. Watch what kids are needing from you in real time. That's what I mean by slow down.
Yes, I understand.
Focus. Pay attention. Yeah. So Doc, you've said something before that really I love, which is and it's it's about what math can do for you when you understand it. And it's like, math is the gateway to science. Math is the gateway. Like I think about kids today, like to understanding AI, to code, to all of these things, right?
Yeah.
And so, like I want to talk about that. Like how do you get kids to see that math is so real world critical?
Yeah, because they're thinking like, why do I need to understand slope intercept?
Right.
Y equals mx plus b.
She hasn't seen this ever.
Yeah, y equals mx plus b. See, this is why we pay people to come in and do things for us that we could do ourselves if we understood math better.
Yeah, that's true.
So true.
That's true.
That's a good way to put it.
Yeah. So you're not going to cheat me. If you're going to tile something for me, I'm going to know how many tiles I need, how many boxes I need. You're not going to tell me. I'm going to tell you.
I know what my overage needs to be.
All right. Yeah. I know my 10% overage needs to be.
Yeah.
I did the math.
Right.
Yeah.
Yeah. So it's like the big chunks of mathematical thinking that, kids need to be exposed to.
Yeah.
And then like, I guess it's about the when and the how that needs to happen, right? Is that?
Yeah, I think that's fair. Yeah. So, as you guys seen me do this before, in my head, I have like the literacy concepts. They take up permanent space in my head, so I can rattle through them.
It's amazing to hear.
Oh yeah. Would you like me to do it?
No.
Okay. Well.
But no, I'm not saying
I'm trying to prove a point.
No, I really love when you do it.
Yeah.
But I wasn't sure.
Yeah, sure. Okay.
If you were joking.
No. Watch this. So I won't go through the whole thing, or I just do a little piece of it.
Yeah.
So kids have to cite evidence. They have to infer. They have to determine the main or central idea of a text or the theme. They have to identify relationships between and among individuals, events, and ideas or concepts or steps in the technical text. Those are literacy concepts. And in the same way, there's a set of mathematical concepts that live inside of domains. And depending upon the grade that kids are in, there are 4 or 5 domains of mathematics to which children deserve calibrated exposure. A classroom that's characterized by focus and coherence around these domains. Procedural fluency, conceptual understanding, application, and dual intensity. So what are those domains of mathematics? K through 8, I'm going to talk about high school in a moment. K through 8, they are geometric concepts kids must understand. They graduate in complexity, but kids must be able to recognize a geometric figure in kinder. They must be able to determine the area of a composite figure in the upper grades. It takes them somewhere. So that's a major domain, geometry.
Okay.
And kinder kids are supposed to learn geometric concepts.
Right. What's a circle?
Right.
Yeah. That's kind of where it starts.
Yeah.
Does it have sides? You know,
Is it round?
it sets them up for radius and circumference later on.
Yeah.
And radii, right?
Angles.
Correct. Right angle, obtuse, acute. It's a setup because they recognize the geometric figures from an early grade, and they weren't taught the bless your heart curriculum.
Bless your heart.
Oh, bless your little heart.
Bless your heart.
Yeah, that poor baby.
Felt like personal.
All right. So for kids in grades K-5, there's an additional math concept. It's called measurement in data, and this is where kids learn or should learn how to analyze information from a chart, a bar graph, a pie chart, and make assertions from the data.
That's where you typically see quarter 4.
Yeah.
Yeah. Measurement.
Yeah. But, you can see kids also, you should see them using a ruler to measure.
Yes.
And you don't have to wait for quarter 4 for that.
You shouldn't.
Right. Right.
See
You
the
could see
science.
them understanding ounces from pounds, gallons from quarts.
Yes.
Yeah.
Because what's waiting for them when they get past 5th grade is statistics and probability.
Yep.
And if you have not been served well with measurement and data in K-5, when you get to stats and probability, you fill that brick wall.
You sure do.
Those are 3 domains of math. Number 4, numbers and operations in base 10.
Yeah.
So numbers and operations is just about kids understanding place value. And that if you have 10 ones, you have a 10.
Yep. And place value constantly comes up.
Yeah.
Yeah.
It's a K-5 concept.
Yeah.
Yeah.
But sometimes it's treated like a 3-5 concept. But the ramp is in K2, so they'd be successful in 3-5. Because what's waiting for them when they get past 5th grade is the number system.
Yep.
And what's the number system? Hell, if you did not master numbers and operations in base 10.
Absolute hell.
Yeah. So the number system is about things like absolute value.
Yep.
And properties like the associative property, the distributive property, the commutative property.
Exponents.
Done.
Right?
Yes.
You're
Done.
cooked, like you said before.
Yeah.
It's well done.
Yeah. So you got geometry, measurement and data, stats and prob, numbers in base 10, and the number system. Okay. And then operations and algebraic thinking is about kids understanding addition. And you might think, what? Yeah, but as early as kindergarten, they need to understand what is addition, what is subtraction, what is multiplication, what is division. How is addition opposite than subtraction? And how is multiplication opposite than division?
Yep.
Yes.
And having those conversations with kids and understanding
Yeah.
the correct terms for once it's solved.
Right.
Yeah.
And algebraic thinking.
Yes.
Like this is like creating a number sentence
Yeah.
and number bonds. Like kids see the number 10 and they know, 5 plus 5. Right? Because what's waiting for them past operation algebraic and thinking and the algebraic thinking in K-5 is expressions and equations.
Yep. So much fun.
So much.
Actually, that is my favorite thing to teach.
Yeah.
Oh yeah, mine too. Mine
Yes.
too.
Yeah.
Mine too. So what's an expression? It doesn't have an equal sign.
Yep.
It has 2 quantities. Yeah. But it doesn't have an equal sign. But an equation is a mathematical statement that establishes equivalence. Expressions do not establish equivalence.
And inequalities as well.
That's right. And like greater than, equal to. But a lot of kids in our country, I still see it more than I would like to. You know, when they're learning less than and greater than, someone's teaching them greater than, like the alligator ate the rabbit. Stop it.
Yeah.
Right.
Yeah. And that's what you hear in the elementary, typically in the elementary school building. And then by the time they get to middle school, it's like, oh,
it's baked in.
It's baked in. Yeah.
It's baked in.
Yeah.
Pac-Man is eating you or running away from
Yeah.
you.
Yeah. But conceptual understanding should have been built. Remember,
Yes.
focus, coherence, procedural fluency, conceptual understanding, application, right? Dual intensity. So a child who's saying that alligator ate the rabbit is being set up to have a lack of conceptual understanding of math concept. They're going to hit a brick wall when they get to the more complex grades and domains.
You're exactly right.
Okay, just a few more. Counting and cardinality. That's a kindergarten concept. Just first, second, third, 1, 2, 3.
Right.
So I say 8 and you grab 8 marbles. That's counting and cardinality.
Okay.
Or like, January is the first month of the year. And you wouldn't think you would have to teach kids that, but kids in kinder, they're blank slates, they're tabula rasas. You got to fill their slate.
So much fun.
Yeah. And counting and cardinality is a setup for numbers and operations, fractions and fractions. If you don't master fractions, somebody's going to take advantage of you.
Yeah. Fractions is everywhere. Literally everywhere.
Yeah, fractions are everywhere. They are. And so it is a 3rd through 5th grade concept. Wow. That a lot of kids get past 5th grade and they haven't mastered it yet. And guess what's waiting for them past numbers and operations with fractions? Ratios and proportional relationships.
Yeah, that's not going to happen.
Yeah, so what are ratios and proportional relationships? They're fractions called by a different name.
Jerry, is this what you taught kids?
I did.
Well, do you need to apologize to them?
No.
All right. And most of 6th and 7th grade is about ratios, proportional relationships, which prepares kids for 8th grade, which is functions. So now, why didn't I mention high school? Because when kids get past geometry, stats and prob, the number system, expressions and equations, ratios, proportional relationships, and functions was waiting for them. Algebra 1, Algebra 2, geometry, trig, and calc. And you will struggle in all 5 of those without this foundation.
100%.
It's truly a foundation.
Truly a foundation.
Yeah. And the gaps only, like, if you don't fill it, it only gets bigger.
Yeah. And goes by faster and gets more challenging and more confusing, and you lose confidence, and all those things happen. Yeah, it's hard.
It is.
You miss one piece in the Lego, or you put one piece in the wrong spot, and you build the whole thing, and it doesn't look like it's supposed to.
Yeah. Unfortunately, in public education, some of the grieves that we bear are needless.
What do you mean by that, Doc?
I read somewhere, that some of the things that we go through are things that we don't really have to go through. We can be preemptive. And so that's in the natural world. So I think it's true in the natural world. I think it's true in the classroom world. That if we plan and deliver instruction that is equally concerned about depth of understanding than it is about coverage, we're going to create a next generation of mathematicians. And unfortunately, and I'm not indicting grade levels or grade bands or teachers, but if I'm trained as a generalist, but I'm expected to teach math like I'm trained to teach math,
right?
Someone's going to get the short end of the stick. And so our professional development has to match what we say we want teachers to accomplish with children. So if I'm an elementary teacher, please give me access to high quality, long-term professional development on teaching math. Because I don't want to produce a generation of 6th graders who feel the brick wall. If I'm a middle school math teacher, please give me access to long-term, high-quality professional learning on both content and pedagogy. So don't assume that I understand as a middle school math teacher functions. Check my understanding of functions so that I can plan and deliver what parents expect kids to be receiving each day, and that's high quality.
Yeah.
And if I'm a professional, I'll accept it. But a lot of folks come into rooms under the guise of receiving professional development. It's not professional, and folks aren't being developed. I think we have to resolve that as a nation.
Yeah, I agree. Right, so what are some types of feedback that we should be providing to students while they're doing the work?
Yeah, that's a good question, Jerry. Kids deserve feedback that helps them to see how well they're progressing through proficiency and on to like advanced level understanding and performance around a small number of math concepts. So when I say good job, I'm not quite sure if kids understand what that means.
Or check mark.
Right. Or 100%. That, I mean, I guess that could mean like I did well, but I think kids need more specific feedback. And they crave it, actually. Mm-hmm. They just have to be taught to crave it because they receive it on a regular basis. And so there are these things, I hate to call them things, but these ideas called Standards for Mathematical Practice. The math teachers and the National Council for Teachers of Mathematics will call them SMPs for short. But I don't really think they should be called Standards for Mathematical Practice. I think they should be called the behaviors of a proficient mathematician. Because if you're proficient in a mathematical concept, you do these things as just a part of your natural behavior. Okay, so what kind of feedback should kids get? They should get feedback like this. Number one, there are 8 of them. Mm-hmm. Good job making sense of the problem and persevering in solving it. Because you could have given up here where you experienced difficulty. Don't give up. So when I was with Kareem, I kept saying to him, don't give up, don't give up, don't give up. So my real-time feedback was, you're doing a good job. You're making better sense of it. Keep going.
Yes.
So I'm gonna use Kareem with these.
Yeah.
To help me to relate what they mean in real time. Reason abstractly and quantitatively. So if you're multiplying a 4-digit number by a 1-digit number, if you reason abstractly and quantitatively, you're going to know that your answer is going to at least be a 5-digit number.
Right.
Right?
Yes.
Okay.
Because you're estimating.
Right. Yeah. Well, because you have sense enough to know that I'm multiplying 5,000 times 5. The number cannot be less than 5,000.
Correct.
Right.
Correct.
Yeah.
Can't be less than 9,000.
Right.
Right?
Yeah. But students have to know to start doing that.
Yeah, they have to be taught to reason and abstractly and quantitatively, which means we've got to use that language with them when they're performing the math tasks.
Absolutely.
Good job using your reason. Reason is just thinking. And you're not just thinking abstractly, you're thinking quantitatively. You're thinking about values. Good. Thinking about values.
That's good.
Another one is constructing viable arguments and critiquing the reasoning of others, which means that a math classroom is a good feedback is feedback that says to kids, show me why you solved it that way and why that way is better than that way.
Yep.
Now look at how your partner solved it. Now, do you agree with that? Is that a good way to do it?
Yeah, that's my favorite thing to do with students, because you can really engage into a conversation of what strategy is best and versus based on the problem that they have. Yeah. And they have that reasoning that I chose to do it this way because it's more efficient
for me as an individual mathematician or budding mathematician. Number 4 is modeling with mathematics, which means at the end of that back and forth that I had with Kareem, the 5th grader, I had him go to the board while other kids were working in pairs because they were ready to keep going. He wasn't embarrassed and I wasn't embarrassed, and they weren't paying attention to him and they weren't picking at him because I control the environment. Right? This is a classroom where folks show respect for kids who want to know.
Yes.
So you don't disrespect a kid who wants to know, because then you have an issue with me. And I'm not threatening kids. I'm just saying to them, you would want the same if the shoe was on the other foot.
Absolutely.
And so Kareem came up to the front of the class with me, and he modeled for me his thinking, and I gave him feedback every step of the way.
Right.
There are others, but I'll end with this one: attending to precision, which is if we are multiplying. If Kareem was multiplying a 4-digit number by a 1-digit number to determine the number of tickets sold, his answer should always be tickets sold. Right. He needs units. He needs to assign the units. And a proficient mathematician doesn't have to be told to do it. They do it on their own.
Yes.
Imagine those historical folks in Hidden Figures not using units.
Right.
Y'all remember that movie Hidden Figures?
Yeah.
And they're trying to get men to space.
Yeah.
And that character, I think she was played by Taraji P. Henson. What if she didn't use units?
Yeah.
Right.
Life or death. Literally.
Literally.
Yeah.
Literally.
Yeah.
All right.
Wow.
Have we helped people with math?
Hope so.
I sure tried.
It's good.
No, I think you've addressed so many great concepts and practices and just like ways to get it done when you're surrounded by all of these pressures, like moving fast, and you have different types of learners, and you've got all these challenging concepts that you need to teach, and you need to meet the standard, and right? It's like
different ability levels in the same classroom, different levels of engagement in the same classroom. But honestly, Richard, I think engagement is less about kids' willingness and more about their comfort, more about their fears.
Absolutely.
Yeah.
Because it looks like a lack of engagement, but it's fear masquerading.
Yeah, you shut down when you're scared.
Absolutely. We all do. No, we all do.
Yeah.
We all do. And when kids are afraid, they don't engage. And so
it's easier to quit than it is to push through.
Sir, you're preaching now. Yeah. All right. Well, thanks everybody for tuning in. We appreciate you being a part of our podcast series here at Educational Epiphany. If you know someone who is grappling to help children to do better academically in mathematics, this is the podcast for them. We hope that you will like it. We hope that you will subscribe if you haven't already, and we hope that you would encourage others to do the same. And so we really appreciate your ongoing support. To stay connected and to learn more about our work around the nation, please follow us on all social media channels at Ed Epiphany. We'd be honored if you would again subscribe to the Epiphany Exchange on YouTube, Spotify, and Apple Podcasts, and visit our website at educationalepiphany.com to explore our wide range of instructional materials and professional learning offerings. And by the way, all links are available in the episode description. Thanks for tuning in. We'll see you next time.
Thanks, everybody. See you soon.